Mastering DynamoDB Operations with Python and AWS Lambda. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. Introduction to AWS DynamoDB. AWS DynamoDB is a fully managed NoSQL database service that provides fast and predictable performance with seamless scalability. It supports key value and document data models, making it suitable for various applications. Overview of DynamoDB's key value and document data model. DynamoDB stores data in tables, which are collections of items. Each item is a collection of attributes. DynamoDB supports two types of primary keys. Partition key, a simple primary key composed of one attribute known as the partition key. Partition key and sort key, a composite primary key composed of two attributes. The first attribute is the partition key, and the second is the sort key. Benefits of using DynamoDB in serverless architectures. DynamoDB's integration with AWS Lambda and other AWS services makes it an excellent choice for serverless applications. Its benefits include scalability, automatically scales to handle traffic. Performance, provides low latency and high throughput. Maintenance-free, fully managed, no server management is required. Integrated security, features such as encryption at rest and IAM policies. Setting up AWS DynamoDB for Python development. Creating tables and defining primary keys. To create a table in DynamoDB, you can use the AWS Management Console, AWS CLI, or SDKs. Here is an example using Python's Boto3 library. Import Boto3. DynamoDB equals boto3.resource-dynamod. Table equals dynamodb.create_table. Table, name equals me, table. Key, schema equals. Attribute, name, primary key. Key, type, hash. Attribute, definitions equals. Attribute, name, primary key. Attribute, type, Z. Provisioned, throughput equals. Read, capacity, units. Write, capacity, units, 5. Print, table status, table.table_status. Configuring DynamoDB connections in Python. To connect to DynamoDB from a Python application, configure the Boto3 client. Import Boto3. DynamoDB equals boto3.client DynamoDB, region_name equals us west2. Understanding query operations in DynamoDB. Using Query API to retrieve specific items based on partition key. The query operation finds items in a table or a secondary index using only the primary key attribute. Here's how to use the Query API. Response equals dynamodb.query. Table, name equals me, table. Key, condition, expression equals key primary key, EQ sum_value. For item and response items. Print item. Optimizing queries for performance and cost efficiency. To optimize queries, use indexes, create secondary indexes for better query performance. Project attributes, return only the attributes needed. Limit results, use the limit parameter to reduce the number of items processed. Deep dive into scan operations in DynamoDB. Utilizing Scan API for retrieving all items in a table. The scan operation reads every item in a table. Example usage. Response equals dynamodb.scan. Table, name equals me, table. For item and response items. Print item. Limitations and considerations when using scans in DynamoDB. Scans can be expensive and slow because they read the entire table. To mitigate this, use filters. Apply filters to reduce the amount of data retrieved. Parallel scans, divide the scan into segments to be processed in parallel. Integrating AWS Lambda with DynamoDB for serverless applications. Writing Lambda functions to interact with DynamoDB. Lambda functions can be read from and written to DynamoDB. Here is an example of a Lambda function that queries DynamoDB. Import JSON. Import Boto3. DynamoDB equals boto3.client DynamoDB. Def Lambda_handler event, context. Response equals dynamodb.query. Table, name equals me, table. Key, condition, expression equals primary, key equals park. Expression, attribute, values equals. Park. Z. Event primary key, return response items. Handling DynamoDB triggers and events in Lambda functions. DynamoDB streams can trigger Lambda functions when data in a table is modified. Here's how to set it up. Enable DynamoDB streams on the table. Create a Lambda function. Configure the stream as an event source for the Lambda function. Best practices for DynamoDB data modeling and performance tuning. Designing efficient DynamoDB schemas based on access patterns. Design your schema based on how your application queries data. Consider single table design. Use a single table with composite keys and sparse indexes. Secondary indexes. Create global and local secondary indexes for additional access patterns. Implementing DynamoDB best practices for scalability and reliability. Use provision throughput wisely. Monitor and adjust read/write capacity. Enable autoscaling. DynamoDB can automatically adjust throughput capacity. Partitioning. Design your keys to distribute data evenly across partitions. Real-world examples and use cases. Implementing complex queries and scans for practical applications. Combine queries and scans with filters, projections, and indexes for complex applications. Case studies demonstrating DynamoDB usage in production environments. Many organizations use DynamoDB for various applications, such as Netflix, for global content delivery and personalization. Airbnb, this is for handling massive amounts of booking data. Conclusion and next steps. This podcast covered the essential aspects of using AWS DynamoDB with Python and AWS Lambda, including setting up DynamoDB, performing queries and scans, and integrating with Lambda for serverless applications. Thank you for listening to our podcast. Please share this podcast, visit our website and follow our social media links.